Hi friends, this is Rahul Kumar from you are watching my YouTube channel. Now I am going to say you next lesson, that's electrical conductivity of liquids. Now we are going into the lesson. Sometimes we read in newspapers about farmers getting electric shock while starting water pumps of wells, especially because of contact made with switches or starters by wet hands. Do you know the reason behind getting electric shock while working with wet hands? Our elders caution us about touching electric heater immersed in water. Why do they instruct you to stay away from it? How does the electric current flow through water? In the earlier classes, you have learned that electric current can pass easily through metals like copper, aluminium, etc. Do you recall some other materials which conduct electric current? Let us revisit the activity and do it now. Now we are going through activity 1. Testing the material to know which allows electric current to pass through it. Again, activity 1. Testing the material to know which allows electric current to pass through it. Take a torch bulb or LED, a dry cell, wooden sheet, 2 drawing pins, a key and pieces of connecting wires. Set up the electric current as shown as the fig 1. Place the key on drawing pin. The bulb begins to glow as soon as the key touches the drawing pin. Now replace the key by a nail. Does the bulb glow? Repeat this activity using different types of materials instead of nail. Say a strip of paper, a piece of chalk, a drinking straw, a piece of plastic, a piece of clip, a rubber, eraser, pencil, graphite, etc. Note in each case whether the bulb glows or not. And enter your observations in the table 1. Take care that whenever the bulb glows should not be kept on position for a long time to avoid the early discharge of dry cell. In the above activity, we observed that some materials allow electric current to pass through them. We call them as good conductors of electricity. In general, all metals are good conductors of electricity. On the other hand, the materials that do not allow electric current to pass through them are called bad or poor conductors of electricity. Electrical conductivity. What is electrical conductivity? Is a property of any given material. We can say that a material has good electrical conductivity if it allows electric current to pass through it easily. Electrical conductivity of liquids. In the activity 1, we have tested conductivity of objects like nail, paper, strip, chalk, etc. All these are solids. What about liquids? Do the liquids allow electric current to pass through them? Let us do another activity to find out whether a given liquid allow electric current to pass through it or not. Activity 2. Now let us move to activity 2. We have completed activity 1, that some solids allow electric current to pass through it. Now coming to activity 2. Testing the electrical conductivity of liquids. Take a LED, dry cell, metal pins, rubber or cap of injection bottle and wires for making connections. Set up an electric current as shown in the figure 2. You are seeing that in the figure 2. See that the 2 metal pins passes through the cap should have very small gap around 2 mm between them so that the pins are fairly close but not touching each other. The LED should not glow when pins are separated by the small distance. Now join the free ends of the pin together by pressing them for a moment and make sure that LED glows. Release the pins, they get separated and LED should not glow. This become our tester. We will use this tester to check the conductivity of liquids. Fill the rubber cap with the different liquids one after another, and in each case check whether the LED glows or not. Start with distilled water. You can get distilled water from battery stores or from medical shops. Pour distilled water in the rubber cap till the two metal pins come in contact with it. Check whether the LED glows or not. Then take water that you drink in school and repeat the procedure. Do this activity with liquids like coconut oil, kerosene, lemon juice, mustard oil, sugar solution, etc. After testing each of the liquids. Carefully wipe and dry the cap and the pins before filling in the next liquid. In each case, note your observation in table 2. From your observations, decide which liquids are good conductors of electricity and which are poor conductors or bad conductors. Note your inference also in table 2. Thank you for watching my YouTube channel. Thank you. Have a nice day.